This is a review and example of the procedure for doing long division with numbers containing decimals. You will note that both of these divisions mean exactly the same thing. 56 and 24 hundredths divided by 0.12 or 12 thousandths. So the first thing we want to do if we're dividing with decimals is actually to get rid of them. We can do so by moving the decimal place the same number of places in the top and the bottom over here, or basically in both the dividend and the divisor. So this one we only need to move it twice. This one, however, we need to move it 3 times. So to keep them even, I'm going to have to add a 0 to my dividend to make it the same number of places that I've moved my divisor. We can also see how that works because when we set it up this way, more like a fraction. Essentially what I'm doing when I move the decimal 3 places is I'm multiplying top and bottom by 1,000. Multiplying both top and bottom by 1,000, it's like multiplying a fraction top and bottom by the same thing. So that kind of shows why it remains the same. Now we're ready to rewrite with the traditional long division notation. And this is where some people get mixed up as to what goes under the division symbol. And what goes under is always going to be the dividend, the thing which is to be multiplied. Or I'm sorry, the thing which is to be divided. So I'm going to write it like this. Note this number is now simply 12 because I've moved 3 decimal places and gotten rid of the decimal. Now I ask myself, how many times does 12 go into 56? I can do scratch work on the side if it helps, but the answer is 4. So I'm going to write 4 up here, and 12 times 4 is 48. So 48 goes down here, and I'm going to subtract. 56 minus 48 is 8, and I'm going to bring down the next digit, which is 2. So now I need to see how many times 12 goes into 82. 12 goes into 82 6 times, so I'm going to write 6 up here. 6 times 12 is equal to 72. So this time my remainder is 10, and I'm going to bring down the next digit, which is 4. 12 goes into 104 8 times. 8 times 12 is 96. So now my remainder is 8, and I'm going to bring down a 0. 12 goes into 86 times, which again is going to be 72. My remainder this time again is 8. But I'll notice I don't have another number to bring down here. So that means I'm going now into the decimals. So the whole number of times that 12 goes into 56,240 is 4,686. There's still going to be a decimal part to that number. So what I need to do next is I'm going to add a decimal to both my dividend and the quotient, which I'm figuring out up here. So now I can add another 0 without changing the value of the dividend, and I can bring that down. And again, I have 80. And again, I know that 12 goes into 86 times. And we're going to run into a repeating cycle here. 6 times 12 is 72 again, so it's a minus 72, which gives me another 8, which I would add another 0, and end up getting another 6. So the way I reflect this repeating pattern is in my quotient. I know this 6 is going to keep repeating, so I'm going to put a bar over it. So now we have our proposed answer of 4,686.6 repeating. This is what we believe our answers to be. But before we conclude that we're done, let's think for a second. Does this answer make sense? And particularly, what I want to think about is if we expect the answer, the quotient, to be larger or smaller than the original dividend. In other words, we're dividing 56.24 by a small decimal number. We want to know how many times a small decimal number goes into this number. Does it make sense that we're getting a bigger number, essentially, than we started with? And in this particular case, the answer is yes, because just to make 1, here we have, this is 12 out of 1,000. So you have to multiply it by several times just to get to 1. So to get all the way to 56.24, it makes sense that we're going to need a big number. Now, of course, we can't just figure out whether this particular number makes sense exactly without doing all the steps below, but we can at least confirm whether we expected a large number or a small number. And from that perspective, I think it's safe to say that this does make sense. So this is, in fact, our final answer. Thank you.